and welcome again to my channel. Today we'll be solving another LeetCode question number 1169, and it is marked medium. Let's first understand what the question wants us to do. So here, this is the question, and the question states that there will be a transaction. It states the condition in which a transaction is invalid, right? And what are the conditions? If the amount exceeds $1,000 or it occurs within and including 60 minutes, right? So two transactions occurring within 60 minutes and have the same name in a different city, right? So the person making the transaction, the name is same, say Alice and Alice, right? But the transaction occurred in a different city within 60 minutes, right? So we'll be given a list of those transactions and we have to filter out the invalid ones. So this is an example test case, right? You can see there's a name of the person, this is the time, this is the amount, and this is the place. Again, name, time, amount, and place. We can see this is the format here. As if you see, we'll have name, time, then amount, and city in the form of comma separated values, like comma separated strings. Okay, so we have to basically return those ones that are invalid. So of course these two are invalid, as the first transaction happened at 20 minutes and the second one happened at 50 minutes. So the difference between these time is 30 minutes. So that is an invalid transaction because the city is also different, right? If the city would have been same, then this could have been a valid transaction. But since the city is different and the time limit is within the one we were given, 60 minutes, so the difference is 30 minutes. So that's why these two, both of them are invalid transactions, right? So let's see how we'll solve this question. So since the input is in the form of a string, but as you have noticed there are multiple parts to that string, we cannot process the string like this, right? So we'll have to create objects out of this. Now what would the object contain? It will be of type transaction. It will be of type transaction, and the field of this transaction object will be, of course, name, city, time, and amount. And there will be one more field called raw. This raw field will contain the entire string, okay? Because ultimately we have to return that in the end, right? So we need to keep track of that as well. This raw field will store the entire transaction in the form of a string. Let's get to coding. We'll solve this question part by part because it is quite confusing as we move along. So we'll explain something and we'll write the code for that, and that's how we will move forward. So the first thing we need to do is declare a type that we are trying to make from the transaction. So something like type transaction struct, and the fields would be name string, city string, time int, amount int, and another one called raw, and it will be string. Okay, so let's make this and convert all the transactions available into this format. So we'll have to make an array, pass array of type transaction. It will be of length n, and n will be length of transactions that we get as the input, right? Now for I, comma t range transactions, we'll have to first deduce the paths, right? So paths equal to strings dot split t at the comma, because they are comma separated, right? Then time will become parts of which one? The time comes in the second place, so parts of 1, right? First index. Same amount parts of third, right? No, parts of 2. Sorry. And then we can add this to the parsed array, right? So parsed of I will be type transaction name will be parts of 0. It is already in string format, so we have not done any conversion here. We have only converted time and amount into int, right? And city parts of 3, because it's the last one. Time will be time, amount will be amount, and the raw will be the entire transaction itself, right? Okay, so now we have converted the input transactions, which was an array of string of transactions, into this parsed format, right? Into this transaction type. Now we can operate on it. The next step that we need to do is pretty easy to understand, and that is making an invalid array, right? This will contain all the indexes that contains transactions that are invalid, right? So invalid will make an array of bool and n, right? Length n. So every index of the invalid will point to the index that has an invalid transaction, right? So imagine if there is an array like this and indexes are 0 1 2 3, right? Let's say this is false, this is false, this is true, and this is true. So this is the invalid array, right? So this array tells us that the transaction at the index 2 is invalid. The transaction at the index 3 of the past array, right? The index 3 of the past array is invalid. The transaction at the index first of the past array is not invalid. So that's what this array will tell us, and we'll fill this array with either true or false as we move along. So the second condition, so the first condition of a transaction being invalid is pretty simple. It cannot be more than $1,000, right? So that means what we can do is for I comma t range past, right? We'll traverse over the past and check if any transaction amount is greater than 1,000. So if t dot amount is greater than 1,000, that means it is invalid. So invalid of I will be true, right? So that takes care of the first condition. Now we need to work on the second condition, right? So for the second condition, there are three things we need to consider, right? There are three things we need to consider, which is the time. It should be within 60 minutes to be invalid. The name, it should be the same name, and the city, it should be a different city, right? So how to work with that? We have to take care of three things, right? City, name, and the time, right? So what we will do is we will compare the city and the time. We'll compare like t1 dot city not equal to t2 dot city and t1 dot time minus t2 dot time is less than equal to 60. So these two conditions will take care of city and time for us, right? But we need to make sure the name is also same, like the transactions t1 and t2 belong to the same person, right? So how will we take care of that? What we will do is we'll make a map called by name, right? What this will have is something like this. It will contain a name, let's say Alice, and it will contain all of Alice's transactions, and we can compare among those transactions the two conditions that we already saw, these two, right? So first we need to make this map, right? And then we can traverse for each person the transactions of each person, right? So how will we make that map? So we'll say something like by name is a map of string to an array of int, right? Now what is an array of int? Array of int again refers to that index that contains the transaction, right? Let me show you what I mean. So we have till now a parsed array, and now we are trying to make a by name array, not array, map, right? So what by name will contain, as I said, it will be Alice, and it will be an array of uh, indexes, right? So that means, let's say 1 2 3. This will tell that the transactions that this parsed array contains, it is an array, right? The parsed array, say in the 1 2 3 4 5, right? The transactions of index 1, index 2 and index 3 belong to Alice, right? That's what biname is trying to do, or we're trying to make biname in such a way that every index for every name refers to the transaction containing in that is contained in the past array, right? So let's make the by name array. So as we are already passing over the past array, right? So we can fill up the by name map here only, right? So what will we do? We'll say by name of t dot name, because we want the map key value pair, right? So the key should be the name, so that's why by name of t dot name equal to append by name of t dot name, basically append this index for that name, right? And now what we'll do is we'll pass over this by name map. So for I comma indices of range by name, right? So this I will not use it, I think, so we can just skip it. So what does this indices variable mean, right? As I told you, we are storing for every Alice, or for every name, we are storing an array of ints. And what are these ints? Nothing but the indices of the parsed array. So that's why whenever we parse over my name, the key will be this, and the value will be an array of numbers, right? So that's why indices, this is the array of numbers or indexes, right? So for I 0, I less than length of indices I, plus plus for j I plus 1, j less than length of indices j plus plus. So what we are doing now with nothing but we are again traversing the indices array using I and j, 2 pointers, right? And this is a double for loop that is traversing over the indices. So t1 will be passed of, we want an index, and index is containing within the indices array, right? So indices of I, right? And t2 will be passed of indices of j. And now we can for sure tell that these two transactions belong to the same person because we have grouped them by name, right? We are traversing over it, so we know for sure that these two transactions belong to the same name. So we don't need to check for that condition now. We only need to check the time and the city condition. So we'll check if abs of t1 dot time minus t2 dot time is less than equal to 60. Basically difference should be less than equal to 60 within 60 minutes of time, and t1 dot city not equal to t2 dot city, right? The city should be different. Then we'll include this in the invalid array. Invalid of, again, indices of I equal to true, invalid of indices of j equal to true. Now we have filled up the invalid array. Now it's time to pass over it, right? And make our final answer array. Answer will be array of string, right? Because we'll be passing over the raw string, raw transaction string in the answers array, right? So for underscore comma val range invalid I here, if val is equal to true, that means the transaction is invalid and we can include it in the answers array, right? So answer equal to append answer comma past of I, because that is the invalid transaction and we want to use the raw field there, right? That's what we want to append to answer, and we'll return answer. Okay, so let's see if it works or not. Okay, I got a comma. Okay, I forgot to write the absolute function. Ps x int x is less than 0, return minus x, return x. The test cases are passing. Let's try submitting, and it is accepted. So this was a solution for this question. Hope you understood the intuition behind it, the logic as well. Try doing it yourself. Try running the code. It will help you understand better. And if you like the video, please subscribe, and I'll see you in the next one.